Hello everybody, I am Ayush Prasad from the Fantastic Academy. In the last video about work, I challenged you to think about 4 simple machines. Now obviously answers are going to vary, but here are a few that we've come up with. Corkscrew, aka bottle opener, bike, a slide, wheelbarrow, and an axe. Okay, now that quiz questions covered, we can talk about stuff. Now, instead of covering classical mechanics, like the last few videos have been about, we will cover something a little more subtle. Light itself. No, seriously, light. Have you ever thought about it a lot? Well, in this series, you learn everything you need to know about light. In this video, we're going to learn about the history of light. Okay, so one of the first theories about light was the Greek theory about light. Let me explain. Let's assume you have a wet pillow here. The way you see this wet pillow is light is coming out of your eyes onto the pillow, bouncing back into your eyes, and you see a wet pillow. Obviously, light doesn't come out of your eyes, but took a smart man called Alhazen to figure that out. So what Alhazen did is that he had 2 dark rooms separated by a wall, and he put 2 holes in that wall, and there were 2 lanterns behind each hole. Now, obviously, they created 2 light spots on the opposite wall, but if he covered either lantern, its respective light spots disappeared, proving that the Greek theory couldn't be right. Instead, Alhazen theorized that the reason you see a wet pillow, that light comes from a source of light, which is basically anything that creates light, then it bounces from this wet pillow into your eyes, and your eyes are like, oh, that's a wet pillow. Alright, now let's talk about light in the Renaissance. Now, another guy called Newton had a brand new theory about light. But to discuss more about Newton's theory, we first have to understand prisms. Okay, so now let's talk about Newton's prism experiment. There are 3 things that you need for this experiment. 1, a bright source of light. 2, some paper. And 3, a prism, which is essentially just a big piece of glass shaped exactly the right way. Now, when you shine light through the prism, it makes a rainbow. And the rainbow has 7 colors: red, orange, yellow, green, blue, indigo, violet. You can remember it with the mnemonic ROY-G-BIG or RIBGYOR. Either of those 2 mnemonics will work. Okay, so now this was Newton's prism experiment. What he concluded was that light is made out of many tiny little balls called corpuscles. And each corpuscle has a different color. And when you have equal amounts of every color of corpuscle in the same place, you get white light. And what the prism is doing is separating the different colors of corpuscles. Okay, reasonable theory, seems to make sense to me, but it's not the correct theory of light. To learn more about light, let's talk about the competing theories that Newton had to face. Now, Newton's prism theory wasn't that absurd. I mean, you might think, Well, light's made out of different color balls with different color. That sounds perfectly reasonable. But another guy named Huggins had a different idea. Huggins thought that light was a wave, and the rainbow effect of prisms could be explained if that wave had different speeds in different objects. See, only Romer's calculation of the speed only included the speed of light in air. But what if, and I'm saying a big what if here, what if light had different speeds in different objects, which it does, by the way. Then that could explain the prism thing. Now, one of the major backers of this theory was Thomas Young. In 1801, he did what's called a double slit experiment, where it was essentially a box, and on one side of the box there were two holes, and they shone a light through the two holes. Now with the corpuscular theory, you would expect that they were just two bands of light, but there were zillions of bands. And the way Tom Young explained it is something called diffraction. Say these are the rays of light, and this is the barrier. Now, when the light passes through the slit of the barrier, it doesn't continue going like this. It goes like this. So it becomes like a circular ray of light. And if you just draw those circular rays coming from each slit on a piece of paper, then you can clearly see that would produce the band effect. Now, there's another guy called William Herschel who is credited for discovering Uranus, but his not so maybe famous experiment was to do with light. See, he shone light through a prism on the paper like Newton did, but then what he did was he measured the temperature of each band, and then he found that the dark space beyond red light had high temperatures. This led him to believe that there were some heat waves, and those heat waves were another color of light, just like Vibgyor, that we just couldn't see. We now call these heat waves infrared light. By the way, night vision cameras work by using infrared light because basically every object with a temperature above absolute zero produces infrared light. It's just that some objects produce more of it than others, including living things, so you could easily see the distinction between a living thing and something that's not alive using a night vision camera. Then Johann Ritter decided to do exactly the same thing as Herschel, but he decided to test the band beyond purple instead of the band beyond red. And what he found was that chemical reaction happened quickest in that area. We call them UV rays, but back then they were called oxidizing rays. Now this led the scientists to believe that light was in a spectrum, and each spectrum, each line in that spectrum, each speck of the spectrum, if you want to call it, was a different wavelength of light, and this spectrum was infinite, and only the tiny sliver of light we can see. Only a tiny amount of specks in the spectrum we can see. Okay, so that was the battle of particle theory and wave theory in the Renaissance-ish period. But now let's come on over the next century-ish. So a guy named Maxwell, his name is Maxwell, he calculated that the speed of light was the same as the speed of electromagnetic waves. The corpuscular theory, the particle theory was dead. Electromagnetic waves are light. Or was the particle theory dead? Because Max Planck and his new quantum theory saw that light was a particle. And Albert Einstein showed that the particle theory of light could explain the photoelectric effect. Think of the photoelectric effect as light and electricity exchanging houses. So when the photon moves to the electricity's house, it kicks the electricity to the photon's house, which is why if you shine light on a metal, it kicks all the electricity out, and some electricity can escape, and we can detect that. So together they resolve the issue. Light is neither a wave nor a particle. It's both. This wave-particle duality, as it's called, set the stage for modern quantum mechanics. But that's a story for another time. Now before we leave, here's a quiz question. Which scientist performed the double-slit experiment? Did the double-slit experiment support the Huygens theory of light or the Newtonian theory of light? We'll answer this question in the next episode of Live